ultrasonics, ultrasonic sound. So the range of hearing is 20 hertz to 20,000 hertz. That is 20 hertz to 20,000 hertz means 20 kilohertz. And the sound below 20 hertz is called infrasonic sound, and the sound above 20 kilohertz is called ultrasonic sound. And now we are going to discuss about what are the uses or what are the applications of ultrasonic. What are the applications of ultrasonic sound? The first and important application is that non-destructive testing. Non-destructive testing, which is simply called NDT, which means that if there will be a hard material and there is a small break or small flow in the or small hole in this area, we want to find out what where the hole is inside the material, and without breaking that material, by using ultrasonic wave we can find where the hole is and where the break is and what width and what length the breaks are or what length the holes are, like that. So we are allowing ultrasonic waves are pass through the material and without breaking the material, using the time interval between the incident ultrasonic wave and the reflected ultrasonic wave, we can find where the hole is or where the break is, like that. So non-destructive testing of a material, ultrasonic waves are used. The second one is that in medical field, echocardiography uses ultrasonic waves to find the picture of the heart. Echocardiography. Again, ultrasound scanning, which uses to find out the pictures of the internal organs, uses the ultrasound waves to using the ultrasound waves to take the pictures of the internal organs. So in medical field, echocardiography and ultrasound scanning, ultrasound waves are used, and in the industrial field for non-destructive testing, ultrasonic waves are used. And one more important application is that sonar. Sonar means sound navigation and ranging. Sonar means sound navigation and ranging. It is used to find the position or the location of submerged submarines or the particle inside the depth of the sea, like that. So here inside the sea there will be a submerged submarine is here, and an ultrasonic wave is allowed to pass through the sea. When it hits the submerged submarine, it is reflected back. So by noting the time interval between the incident ultrasonic wave and the reflected ultrasonic wave and using the equation of the distance, velocity and time, we can calculate where is the position of the submerged submarine. How can we use? As we know that distance is equal to speed into time or velocity into time. So velocity is equal to distance by time. So V is equal to distance is, here we take the distance as 2d by time is t. Why there will be 2d? Because from here is the, if this is the source, then from here to here it will be the distance d, and the incident distance is d, and the reflected distance is also d. So therefore d plus d is, the total distance is 2d. So we can find out the distance, d is equal to vt by 2. By using the equation we can find the location of the submerged submarine or any other particle located at a particular point inside the sea or anywhere. So this is sonar. So sound navigation and ranging also uses ultrasonic waves to find the distance or find the locations inside the depth of a sea. So this is all about sonar and ultrasonic waves. Moving to the last portion of the chapter called human ear. In this portion, we discuss about how a sound interprets by the human brain or how a sound is heard by the human. So this is the picture of a human ear, and for more simplification, we just draw a flow chart here. External sound, pinna, auditory canal, eardrum vibrates, sound signal amplified by three bones, inner ear, electrical signal, auditory nerve, and brain. This is a flow chart connecting how a sound is heard or how a sound is interpreted by the human brain. Right now, these are the parts of the human ear called outer ear, middle ear, and inner ear. Outer ear consists of pinna. In middle ear consists of these all things. That means in the middle ear there will be three bones called hammer, anvil, and stirrup. There also the inner ear consists of cochlea, and then the signal is converted to signal is transmitted to human brain through auditory nerve. So these are the three main parts of the human ear called outer ear, middle ear, and inner ear. So first thing happen is that the sound from the external surroundings is transmitted to pinna, that is collected by the pinna. The sound from the external surrounding is collected by the pinna called outer ear. So the outer ear called pinna collected the sound from the external surroundings. Then it allow the sound to pass through the auditory canal, allow the sound to pass through the auditory canal. So first what happens, the external surroundings, from the external surroundings, the outer ear called pinna collects all the sounds and allow them to pass through the auditory canal. At the end of the auditory canal, there will be eardrum. At the end of the auditory canal, there will be eardrum. With respect to the sound wave, the eardrum vibrates. So sound signals are produced. So the thing is that the sound from the external surroundings collected by the outer ear called pinna, and pinna is allowed that collected sound to pass through the auditory canal. At the end of the auditory canal, there will be eardrum. With respect to the sound wave collected by the auditory canal, the eardrum vibrates and sound signals are produced. That sound signals are amplified by three bones called hammer, anvil, and stirrup. That sound signals are amplified by three bones called hammer, anvil, and stirrup. That amplified sound signal is transmitted to the inner ear. That amplified sound signal are transmitted to the inner ear. That means cochlea. Cochlea converted that amplified sound signal to the electrical signal. Cochlea converted that amplified sound signal to the electrical signal. Then that electrical signal is traveling to the brain with the help of auditory nerve, and the brain interprets what we heard. This is the things what that happening in the case of a human ear. So once again, what happens? The external sound is catching by, or the external sound collected by the outer ear called pinna. Pinna allows that catched or collected sound to the auditory canal. At the end of the auditory canal, there will be eardrum. With respect to the sound wave, the eardrum vibrates and sound signals are produced. That sound signals are amplified by three bones called hammer, anvil, and stirrup, and the amplified sound signal is transmitted to the inner ear. So inner ear called cochlea. Here at the part cochlea, the transmitted, that means the amplified sound signal is converted into electrical signal, and that electrical signal is then transmitted to the human brain through auditory nerve, and thus the brain intercepts what we heard. This is the working of the human ear and how a sound is heard by the humans. These all are the things in the last portion of the chapter. So that's all about the chapter sound. And now what we are studying in this chapter. We want to recollect all the things that we are studying in this chapter. Okay, so starting from transverse wave, then transverse wave, then longitudinal wave, then characteristics of wave. In characteristics, what we study? Characteristics, we studied about frequency, wavelength, amplitude, velocity, time period, relation between frequency and time period, relation between frequency, velocity and wavelength, like that. Then fourth one is characteristics of sound. Characteristics of sound, that is pitch, intensity, loudness, tone, are related to that. Then fifth one is multiple reflection. Then sixth one is echo. Seventh one is reverberation. Eighth one is range of hearing. From range of hearing, we already studied about ultrasonics and infrasonics. Range of hearing, ultrasonics and infrasonics. Then application of multiple reflection. Multiple reflection. Application of ultrasonics. In application of ultrasonic, there will be important two things. That is, number one is NDT, industrial application. Then there will be a medical application, and finally there will be sonar. NDT, medical application, and sonar. Then last one is human ear. So starting from transverse wave and longitudinal wave, and at the end there will be human ear. These are the important concepts in this chapter. And this is Sudhi signing off from this chapter, and we will see you in the next class, and thanks for joining in this class. Thank you very much.